ever wanted to track exactly when a computer turns on or off without buying expensive software? Here is how to build an automated tracking system using Windows, PowerShell, and Google Sheets, completely explaining how the code works under the hood. Welcome to another video on Workflow Architect. Let's get started implementing the solution step by step. Step 1. Prepare your cloud database. Open a new Google Sheet. Identify the column names like date and time, event ID and event details. Now head up to Extensions and open Apps Script. Here, we write a JavaScript function called doPost. This function listens for web requests. When it catches one, it takes the incoming JavaScript object notation text packet, passes it back into readable data, and uses the sheet append row command to instantly slide a new line of data into the bottom of your spreadsheet. Once your code looks like this, click Deploy, create a web app, and critically, set the access permissions to anyone. Copy your unique web app URL. This link serves as your secure endpoint in the cloud. Step 2. Extract and send the local data. On your Windows machine, we use a PowerShell script. The magic happens using the command getWinEvent. We feed it a filter hash table, looking specifically inside the system log for critical event I.does6005 captures when the logging service boots up. The script loops through these discovered events, translates the timestamps into a standardized date and time format, and packages the ID and descriptions into a clean JavaScript object notation data object. Finally, it calls invoke REST method. This command acts as a web browser, firing an HTTPS POST request over the internet to shoot that JavaScript object notation data object payload directly into your Google web app URL. Do not forget to paste your web app URL you copied in the previous step here. Let's run the task manually to verify that our PowerShell script is successfully pulling the data from the Windows event logs and pushing it over to our Google Sheet. Now that our manual test has confirmed the script works perfectly, let's save it. Create a dedicated folder on your C drive, open Notepad, and paste the code. You can name the file whatever you wish, but make sure it has a .ps1 extension. This file will hold our code and act as the core runner for our automation. Here, you can see the finalized script once again. It's incredibly important to remember. Do not forget to paste your unique web app URL right here. Without it, your logs won't have a destination, and your data will never reach the cloud. Step 3. Automate the entire pipeline to make this hands-free. Open the Windows Run dialog, type task schd.msc, and hit Enter to launch the native Windows Task Scheduler. On the right-hand panel, click Create Task and name it Windows Logs Query. This is where we instruct Windows exactly when and how to run our automation. First, switch to the Triggers tab and click New. To keep things simple, change the Begin the Task drop-down to On a Schedule. Select Daily and click OK to save the timing. Next, head over to the Actions tab and click New. Set the action type to Start a Program. In the Program field, type PowerShell.exe. In the Arguments field, paste -execution -policy bypass, followed by the exact file path to your script. This critical parameter ensures Windows runs your automation smoothly in the background without throwing security blocks. Click OK on both windows to finalize your settings. Now that the automation setup is completely done, let's run our scheduled task manually to test it out. By right-clicking the task and hitting Run, we can verify if the system successfully fetches the data from the Windows event logs and pushes it straight to our Google database. If everything is configured correctly, your sheet will instantly populate with the logs right before your eyes. And there you have it. By connecting the Windows event log to Google's Backend API via PowerShell, you have a completely serverless cloud updating tracker. It is the perfect, untamperable solution for auditing machine usage, tracking productivity, or monitoring server uptime.